Good morning, my friends and brothers. I remain Wasrum Edward. This morning, I will be introducing a fascinating development in macroeconometrics, which has to do with the quantile regression. The quantile regression is an approach to estimation that requires researchers to actually correct errors that emanate due to issues relating to either model misspecification, the presence of outliers, or when the basic assumptions of the classical least squares have not been upheld or validated. Remember or recall that the classical least square assumptions require that the residual should have a normal distribution and that there should be serial independence of the error term, and secondly that the assumptions of homoscedasticity must actually be upheld. The model must be correctly specified, and that the model that is also correctly specified must be stable. And in many cases, these assumptions are being violated, and when these assumptions are violated after estimation, the post-estimation output of many researchers will actually indicate the presence of violations of these assumptions. And some researchers or scholars will continue or will go ahead to actually publish such results and also have them in their paper. So this morning I will also teach you how to resolve this problem and how to have a better result that will be readable. So the study objective this morning is to teach you how to estimate a quantile regression from Cradle. So let me go back to my EViews worksheet this morning. I will be looking at how globalization affects economic growth this morning. So the first thing I will do is to estimate an ordinary least square, a normal regression, to actually see if there is presence of serial correlation, there is presence of heteroscedasticity, there is presence of other misspecification errors in the OLX estimation before I will then proceed to delve into the quantile regression framework. So the first thing to be done this morning is to go to quick. If I actually want to use an OLX approach this morning, to go to quick, my dependent variable is a log of RGDP. I have my independent variables, the log of foreign direct investment. I have trade openness, and I also included exchange rate in this model. And without changing anything, if I hit the OK button, the method remains the least square approach. The sample size, I'm using quarterly observation from 1996 quarter 1 to 2021 quarter 1. So if I hit the OK button, I will actually be exposed to a least square output that looks like this. The dependent variable is the log value of RGDP. Estimated this day, the 12th day of August 2023, times 757. So this is my least square approach. If you look at this result looks fine, looks fascinating. The Watson statistics is though bad, but the probability value of the F statistics is significant. The F statistics is though over bloated. The R square is 85%. R square adjusted is 85%, means that 85% of variation in RGDP is associated with the interplay of the globalization indices used in this estimation. The probability values are fantastic, very, very significant and readable. If you want to actually interpret this OLS, you can say that an increase in trade openness will cause a decrease in GDP or economic growth in Nigeria. Exchange rate is having a positive impact, while foreign direct investment is having a positive impact. So if you look at it, this actually could be how you will interpret this result. But let's actually check if this result is okay. If there is problem with this OLS results, then we will now proceed to check if there is problem with this OLS result, if this OLS result actually adheres to basic assumptions of the classical least square. To have that done, I go to view, and maneuver to residual diagnostics. I actually want to start with histogram normality test. The histogram normality test, I hit OK. I observe that my histogram normality test has a Jacobi statistics of 0.059, which is less than 5%. That means that there is a problem. this particular distribution do not actually follow the Gaussian condition. Recall that a normal distribution requires that the skewness, although, will be positive, less than 1, which is okay. The cortices would be within the framework of 2, which is okay. But the probability value of the equivariant statistics must be above 5% for there to be normal distribution. Given this condition, and I assume that no, there is no normal distribution in this estimation. And since there is no normal distribution in this estimation, let me also proceed to see if there is a issue relating to heteroscedasticity. I go to view again from the results. I maneuver to residual diagnostics. I move to serial correlation LM test. I will allow the lag specification to remain lag 2, and this is my result. Your attention should be on the first result. This is the first result. This first result is Bruce-Godfrey serial correlation LM test. If you look at the F statistics of Bruce-Godfrey serial correlation test, the F statistics is significant. The observed R square is also significant, which implies that there is a serial correlation in this result. There is an evidence of serial correlation that the assumption of serial independence in the classical least square is violated. And since this assumption is violated, I'm not happy with this result. I'm not comfortable with it. I'll go back again to view. From view, I maneuver to residual diagnostics again. I will now move to heteroscedasticity. This time, I will allow Bruce-Godfrey pagan estimation. If I hit OK, I will now be exposed to 3 more statistical in heteroscedasticity tests using Bruce, pagan, and Godfrey test. And if you look at this 3-in-1 results, this 3-in-1 result shows evidence of heteroscedasticity in the outcome. And if you look at the F statistics, the observed R square, the scale explained SSs, these 3 indicators or indices actually have probability values that are less than 5%. Which implies that there is a problem. There is an issue of heteroscedasticity in the outcome, and the assumption of homoscedasticity is being violated. And since that assumption is being violated, I'm not also comfortable with it. Then the question now remains: will the above result be valid for any meaningful interpretation or policy framework? No. The best thing to be done in this instance, the best thing to be done when you find yourself in this quagmire, is to actually estimate the quantile regression. The quantile regression will now allow you to estimate this particular model again in a different method of estimation. To have that done, I will actually go back to estimate, hit the estimate button in the method box without changing any other thing. In the method box, I will change from least square approach to quantile regression, from least square approach to quantile regression, This is my quantile regression. The quantile to estimate will have from 0 to 1. I will leave it at 0.5 without changing any other thing. My sample size remains how it were without changing any other thing. The estimation method remains hover switch without changing anything. I may also decide to use ordinary least square, but leave it at hover sandwich without changing anything. If I hit the OK button, I will be exposed to a better result. This is a better result from what we had before, but the signs may not have changed anyway. If you look at 6, this is the quantile regression. The dependent variable, the GDP, the quantile method is quantile regression median. The difference between the quantile regression and the previous least square estimation is that the previous least square estimation actually model the mean value of the independent variables on the dependent variable, whereas the quantile regression actually model the median value of the independent variables on the dependent variable. So in quantile regression, we are looking at the median values, the middle point of the independent variables on the dependent variable, not their mean values. That's the difference between the quantile regression and the ordinary least square estimation. So this is my quantile output. So this can be readable. Interpretation should be done using the ceteris paribus interpretation approach. This is my pseudo R square 66%, and its adjusted value is 65%. Then if you look at the quasi LRO statistics, that's remarkably okay. 243 is okay. The probability value is significant, which is marvelously okay. This result is better than what we had previously. Then to actually establish or to determine the previous quantiles processes required to know if it's the other quantile processes, you go to view, you go to quantile processes, you maneuver to process coefficient first. In the process coefficient, we have two frames of it. We have two outputs, we have tables and graph. So in the first place, let's assume that we are actually forecasting on 10 quantiles. 10 quantiles, we leave it at 10. We allow it to be at graph without changing any other thing. If you hit the OK button, you'll be exposed to something that looks like this. You're exposed to a result that looks like this. This is the result. This is what we have actually estimated. If you actually do not want the constant, you would have actually removed the constant from the equation. From the equation, you can remove the constant if you don't want the constant in the quantile regression. We will remove the constant value to enable us have robust result of actually what we wanted. So this is the result, the previous result I just specified. So this is the result. We have the first quantile, the second quantile, the third quantile to the 90th quantile. Interpreting this result is different from actually how we interpret the classical least square outputs. In my next video, I will expressly interpret this result. So to actually get the graphic representation of that particular result, you go back to quantile process again, you go to quantile coefficient, you change from table to graph, you click OK, still remain at 10th quantile, you click OK. You have the graphical representations of the output as is shown this way. These are the quantile process estimation for each of the parameters in the model. So basically, you can also go to view. You can also go to view again. You go to the quantile process again. You maneuver to the slope equality. Slope equality. Remember, you actually were estimating 10 quantile. You change it to 10 again without making any further adjustments. You hit OK. If you hit OK, you actually test required equation estimate with explicit intercept. You hit OK. You go back again. Go back again, process slope equality. You actually click, you alert 10 user specification or coefficient. You move on to quantile process asymmetry quantile. You allow it to be 10. We have the asymmetric quantile output, and in this result, your attention should be strictly at the first phase of this result. Your attention should be strictly at the first phase of this result. If you look at this test summary, we have the chi-square statistics, we have the probability value with the y-first that represents, we have the p-values, and since this p-values is not significant, we now say that is asymmetry. There is asymmetry because it is not significant. But had it been that this p-value is significant, we can now say, sorry, that there is symmetry rather. There is symmetry because it is insignificant. Had it been that the p-value is significant, we would have said that there is asymmetry. So whenever time the p-value of symmetric quantile checks is insignificant, like what we have here, we will now say that there is symmetry in the output. But when it is significant, we say that there is a asymmetry. So this is how you actually estimate your quantile regression. In my next video, I will offer meaningful interpretation to all these outputs one after the other. Thank you for staying tuned to my channel this morning. Please always subscribe to my videos. Advise your friends, students to go through, read through, view, like, and subscribe to my video. I assure you that in subsequent development, I will be introducing and pulling out sophisticated and fascinating development in macroeconometrics. Thank you for staying tuned to my channel this morning. Good morning.